So now let's talk about binary molecular compounds. Okay, so this is basically where we have two nonmetals forming with covalent bonds. Okay, so this is not ionic bonds with the metal and nonmetal. These are two nonmetals, two nonmetals. Now this is a very similar structure, okay, with how we're going to name these compounds. So molecular compounds, all right, the elements are going to be named in order. So the first element is the full name. The second element is the IDE. Very similar though, it's very similar to ionic compounds. So in this case though, just the first, you keep the same. The second, right, IDE. Very similar though. However, here's the difference though. Here's the key difference. You got to use prefixes to indicate the number of atoms. So molecular compounds, we use prefixes. Ionic compounds, we're not using prefixes. So for instance, N2O. N2O. N2O is letting me know, okay, I got a nitrogen here. I got two of them, and I got one oxygen here. Okay. So the first we name in order. Elements are named in order. So our nitrogen will be first. You don't mess with it. We keep it the same. Okay. And then also we have to include the prefix now because this is a molecular compound, two nonmetals. So since we have two nitrogens, it's going to be dinitrogen. Dinitrogen. Second element is an oxygen, so we're going to change that to oxide. All right, so we change that ending to IDE. As well as we must, right, we must give me that prefix. So that's monoxide. So together, this molecular compound is di, because I got two nitrogens. So dinitrogen. Then I have one oxygen, so it's mono for one oxide. And remember to change that ending to IDE. Let's look at NO. Okay, so NO, right, nitrogen and oxygen. This is a molecular compound, right, because they're two nonmetals. How are we going to name this, Dr. J? All right, so we got nitrogen, right? We got nitrogen. We're going to keep that exactly the same. Nitrogen remains the same. We're going to change, though, the oxygen, right? So the second one, the second element, we change the oxygen to IDE, ide. Okay, and then what are we going to do from here? Nitrogen monoxide, right? Because we must give that prefix. Now, here's the thing that I will tell you. Okay, so if it's the first element, you don't have to put mono element for most cases, right? So in this case, right, I'm not going to name this mononitrogen, right? Monoxide, right? It's no need, it's kind of redundant. So we just keep it nitrogen. We keep it simple, we keep it clean, right? So we're going to call this nitrogen monoxide. You don't have to use it for the first one, If it's the second one, like for instance, in this case, the monoxide is needed to indicate, right, that we have that one oxygen. If you're just naming the compound nitrogen by itself, it's implied that there's one nitrogen there, right? Because there's no need to say mono nitrogen. We get it, it's one nitrogen. Okay. NO2, notice I'm just keeping it with the NOs, right? So NO2, we got one nitrogen, right? So I'm going to just say nitrogen. And like I said before, right? No need to say mononitrogen. We get it. It's only one nitrogen. So it's being redundant saying mono. Okay. But we have two oxygens here. Two oxygens. So, right, I'm going to change my oxygen to oxide. OXIDE. Change that ending to IDE. Okay. And then, right, I got two oxygens. I need that di there. So this is dioxide. So we have nitrogen dioxide here. Okay. And then let's look at one more, N2O3. So this is letting me know I have two nitrogens and I have three oxygens in this chemical formula. When it comes to naming them, right, we're going to do, it's going to be dinitrogen and then trioxide, right? Telling me that I got two nitrogens, dinitrogen, and then I have three oxygens, tri for three, and then oxide. Remember, the second element, you change the ending to IDE. So I want you guys to give this a shot. I want you guys to give this a shot. Write the formula for these names. I want you guys to write the formula out here. Okay. So right now I got 3 different examples that are blank. I got nitrogen triiodide, phosphorus pentachloride, tetra phosphorus decasulfide. All right, so right now you know the drill. Go ahead and pause me, give it a shot. All right, and then from here we're going to do these together. All right, so nitrogen. All right, so this is going to let me know that I got one N, right? I got an N there, and then I got iodide. So that means I got an I. Okay, so I got an N and I. This is also telling me that I have a tri here, so I got 3 I's. So I'm going to put Ni3. Okay, so this is my formula for nitrogen triiodide, which is Ni3. If we go to B, phosphorus pentachloride, right? Phosphorus, I know that's going to be a P, right? And chloride, I know that's a Cl. And since this is, no prefix, this is 1 phosphorus, and then pentachloride is letting me know that, okay, I got 5 chlorines. So my formula should be PCl5. PCl5. Then lastly, we have tetraphosphorus decasulfide. Okay, so I got phosphorus and I have sulfur as my 2 elements here. Okay. Tetra is 4, deca is 10. Okay, so I have 4 phosphorus and 10 sulfurs. How are we going to write this chemical formula out? Right? It's going to be P4 S10 for decasulfide. So we write it down P4 S10 as our final chemical formula. So what we're going to see here, right, is, to be honest, writing a formula and naming these compounds, molecular compounds, I kind of find easier than ionic compounds. Ionic compounds kind of take a little bit more practice and work. These, of course, you need to practice and work with them, but you can tell, right, it's a lot easier to write the formulas when you're given a name here. Make sure you guys go ahead and continue to practice.